So much drama in the LBC. It's kind of hard being Snoop D-O double G, but I somehow, some way keep coming up with funky ass shit like every single day.
Okay, number 2 asks us to use logarithm properties to expand each expression. So now we're just going backwards using log properties as well. So we see this here. This is log of square root of x to the third times y to the negative fourth. So the first thing we can do is actually kind of rewrite this, right? So on the inside, this says square root of x to the third times y to the negative fourth, right? And this square root sign can actually be interpreted as a 1/2 power. So we have something that looks like this. So to the 1/2, the positive 1/2 power, that is. Okay, and we can just use normal like exponent properties, not of logarithms or anything special like that, but just multiplying or distributing this into each of those exponents. So we're actually going to get x to the 3/2 times y to the negative 4/2, which is negative 2 power, right? So now we actually have this thing inside of our log. That's the same thing as saying log of x to the 3/2 power times y to the negative 2. Okay, so this is actually the problem that we're solving. I just simplified it a little bit. So if we, I'm going to write this down over here in the empty space. So log of x to the 3/2 times y to the negative 2. This is the same as saying, since we're multiplying two things, we can actually separate them because we're trying to expand right now, right? So we can expand these using a plus sign in between. So this is like log of x to the 3/2 plus log, common base, time of y to the negative y to the negative 2 power. I was trying to say 1/2. Anyways, okay, so now that we're at this point, we can just use the exponential property of logs to move these exponents down in front, okay, and just make them coefficients on the log that they're in. So ultimately, we're going to get 3/2 times log of x, and then minus 2 times log of y. Okay, and that's how we expand part A. Let's work on part B on the next slide. Alrighty, so for part B, we have ln of y times the square root of y over 1 minus y. So a lot of y's going on here. So the first thing we see is that we have a y times, so a product, times the square root of something, right? So this is going to give us, we can actually break this up using the sum property. Okay, so we have ln of y plus, we can stick a plus sign in there, and then write ln of the other thing, which I'm going to rewrite right now as y over 1 minus y, all to the 1/2 power, right? Because 1/2 is the same thing as square root, right? And then we can distribute this exponent here. Okay, so this is going to become ln of y, and then plus ln of y to the 1/2 power over 1 minus y, quantity, to the 1/2 power. Okay, so now we see that we have something being divided by something else inside of a log. So that kind of gives us a hint to use the difference property of logs, right? So now we just have our normal ln y out in front, and then plus, and this is going to break up into ln of the top thing minus ln of whatever's on the bottom. So that's going to be a 1 minus y to the 1/2 power. Okay, let me see, I think I need one more parentheses there. Okay, and now all we have to do is just move these exponents right down in front there of our logs. Okay, so we're going to get ln of y, and then plus 1/2 ln of y, and then minus a 1/2 ln of 1 minus y. Okay, and the very last thing is we can't really break this up anymore, but we do see that these here are like terms, so we can just add the coefficients. So the coefficient of this one is just a 1. So 1 plus 1/2 gives us 3/2. So we're going to end up with a 3/2 ln y minus 1/2 ln of 1 minus y.
With my mind on my money and my money on my mind.